Hey guys, so today we're going to learn how to use the remainder theorem to determine some things about dividing polynomials. So the first thing I want to point out to you is a couple of things that we need to know about the remainder theorem. And let me zoom in a little bit here. You should have this PDF in Canvas that you can download, and I will also provide it for you in class. So when we're looking at a polynomial f of x, and it's being divided by, say, x minus c. That's what we've been doing this week. So let me give you an example of kind of what I'm talking about. So for example, if we were taking, let's say 4x cubed plus 2x squared minus 5x plus 4, and we were dividing it by, say, x minus 3. That's what we're talking about. Okay, so what the remainder theorem says is that if you find just this c right here, ignore the negative, okay, for a minute, and you look for the remainder is going to be whatever f of c is. So in other words, if I found f of 3 up here, then my remainder from this division would be that. Now, the reason that that is important is because if f of c equals 0, okay, if I were to find f of 3 up here and it was to equal 0, then you would know that x minus c is a factor of that polynomial. That's what it would tell you. If f of c does not equal 0, then the remainder is the number that you found when you evaluated f of c. So let's make that practical by looking at an example, and I think that'll help you understand better what we're talking about. So here it says evaluate each function at the given value. So if I'm going to evaluate this function for f of 3, that means that everywhere I see an x, here, here, and here, I'm going to put in the number 3 and see what I get for y. So I'm looking for f of 3. So I'm putting in 3 cubed minus 7 times 3 squared plus 5 times 3 minus 6. Okay, now I'm going to tell you that the easiest way for you to probably do this is to key this right here in Desmos. And I've actually already done that for you. So let me go to Desmos here real quick. And you can see here that up here at the top, this top one that I'm highlighting right here, this is the one where I filled this in. 3 cubed minus 7 times 3 squared plus 5 times 3 minus 6. You can see here that we get y equals negative 27. So if I go back to here, I know that f of 3 equals negative 27, okay? Now, we're going to talk about what that means in just a few minutes, but right now what that means is if I were to divide x minus 3 into this, my remainder would be negative 27. That's what my remainder would be, okay? Let's look at number 2. Evaluate this polynomial for f of negative 2. So I'm finding f of negative 2. That means everywhere I see an x, I'm going to put negative 2. So 4 times negative 2 cubed plus 5 times negative 2 squared minus 6 times negative 2 minus 4. And again, I'm going to challenge you to go to Desmos to do that. So you can see I've already done that right here. And I get negative 4. So I know that f of negative 2 equals negative 4. Now what that means, since this is f of negative 2, my factor would be x plus 2, okay? And since this is a number, that means if I divide x plus 2 into this polynomial, my remainder would be negative 4, okay? And I numbered this incorrectly. This should be number 3. I just noticed that. And this should be number 4 down here. So let's look at number 3. Now this time, notice the directions say, state if the given polynomial is a factor, that's key, of the given polynomial. Now, in order for it to be a factor, let's go back up here. If f of c equals 0, then x minus c is a factor. So what I want to see is if I fill in this c, whatever my x minus c might be, if I get 0 as my remainder. If I do, then it's a factor. So here it's x minus 3. So I'm looking for f of 3. So I'm going to come over here into my polynomial, and everywhere I see an x, all these 3 places here, I'm going to put a 3 in. So that's 3 to the 5th minus 2 times 3 cubed minus 3 squared plus 2. Okay, again, I'm going to go to Desmos and get that. I've already keyed it in. It's this one right here. And I get 182. So my answer there is 182. So I'm going to write here that f of 3 is 182. Well, 182 is not 0. So remember, in order for x minus 3 to be a factor, this number needs to be 0. Well, since it's not, I can say that x minus 3 is not a factor. And this is our answer. X minus 3 is not a factor. Okay, if we look at number 4, this time we have x plus 4. So that means I'm looking for f of negative 4. It changes the sign of what's in there. Okay, looking for f of negative 4. So if I fill in negative 4 everywhere I see an x in this polynomial, that's going to be negative 4 to the 5th minus 3 times negative 4 to the 4th minus 28 times negative 4 cubed plus 5 times negative 4 plus 20. And again, I'm going to go to Desmos and see what that is. I've already keyed it in. So it's this one here. If I can get it to highlight, this one. And I get 0. Okay, so f of negative 4 equals 0. If it equals 0, then that means that x plus 4 is a factor. So my answer is x plus 4 is a factor. That would be our answer. All right, guys. As always, if you have questions and you're working from home, you can email me and let me know, and I'll try to answer those questions.